Today's video is sponsored by no one. If you haven't seen episode 1, this is I make a video game and put it on the internet because otherwise I will not finish making it. Today's episode is about visual polish, primarily about walking through how to make a fake lighting effect. So with that being said, let's get started. No one? No. Okay, I thought someone would join in on that. That's okay. The first thing we are going to do is create an empty game object in Unity and attach a script to it. We're also going to need a mesh filter component. I'm going to set the type to quad. We're also going to need a mesh renderer component, which is what makes any mesh visible to the camera. So it's pretty important. The sprite renderer also requires a material in order to render, so I'm going to quickly make a basic material and just set the shader to be the default sprite shader. So right now our object will just look like any other sprite in the game. With that out of the way, we can begin programming. The first thing we want to do is make a circle. So to start, we're going to create an integer called accuracy, and this is going to calculate how many points on the circle we want to make. I'm picking 30 completely arbitrarily. That's almost certainly too low, but this way if we do something too computationally expensive by accident, then at least it only happens 30 times and not hundreds of times every single frame. I also made an empty mesh filter variable, which is literally useless right now and we're not using it at the moment. However, I did it in this order for some reason, so yeah, I'm gonna put it in the video here. Inside the update function, we wanna make a for loop, which is going to calculate all of the points on our circle every frame. To do this, we want to figure out the size of the arc between each point, which is fancy radian math talk, but in degrees it just means what degree apart is every single point on the circle. We can calculate this by dividing 2 pi, which is essentially 360 degrees, which is a full circle, by 2 pi. Then we're going to store the XY coordinates of this angle in a vector 2 using some basic trigonometry. Then we're going to use Unity's drawArray method to display a line at that angle at an arbitrary length, in this case 5. Because they're debug rays, they're only visible in the scene view, so I'm going to split the screen so we can look at both the scene and the game as it's playing. As you can see on the left, it looks like we did a great job with circles. So now that we've graduated preschool, let's make our mesh. First things first, let's finally give our mesh filter a value. After that, we're going to create a mesh object and we're going to set the mesh filter's mesh value to mesh. And I know that's a lot of mesh, but pretty much what we're saying is hey, let's make a mesh and then let's put it on our mesh filter. I then added a float for radius just because, then we don't have to use arbitrary numbers. I probably should have done this at the beginning, but I'm doing it now, so, we're gonna work with it. There are 3 key things to know about making a mesh in Unity. The first thing is the vertices, which is just all the points that the polygons of a mesh can connect to. The second thing are UVs, which is essentially a projection of the mesh onto a 2D plane so that you can map textures to an object. But because we're doing a 2-dimensional object, the UVs and the vertices will be exactly the same. So anytime we want to create a vertice, we also want to make a UV and give it the exact same value. Last are the triangles, where you list the index of 3 vertices at a time, and then a triangle is drawn from those points. It is important to note that the order of your vertices for triangles matters, because if it's a clockwise order, it'll face the camera, whereas counterclockwise it'll face against, just something to keep in mind if you're doing any mesh creation. You'll notice that the size of these arrays are accuracy times 3, and the reason for that is because we're going to be adding 3 points of data to each of these arrays inside of the for loop based on how big accuracy is. In this case, the 3 points will be the center of the circle, the point on the circle that we calculate, and the last point on the circle that we calculated. If you think about a pie, essentially what we're doing is turning one pie slice into a triangle on our mesh. In order for this to work, we need to store our currently calculated point at the end of the loop in order to use on the next iteration. I then realized I was using the loop iterator to determine where in the array the vertex data should be stored, so I quickly made an integer to count the vertices as we make them. Like I said earlier, the UVs are going to be exactly the same as the vertices, so we're just going to copy the data from the vertice array to the UV array. Finally, we create a triangle by inputting the index of the 3 vertices we created. With that done, we just have to apply the data to our mesh, and it was then I realized that my mesh was not in the correct scope, so I just moved it above the start method. It was then I got an error telling me that vertices needs to be a vector 3, not a vector 2, and UVs need to be a vector 2. However, it took me a little bit of time to figure that out, so you gotta watch me stumble around as I try to make sure all of the variable types are correct. And with that, we can write all the data to our mesh. But don't forget to remove the code where we apply the mesh data to outside of the for loop. And in editing, yeah, it's gonna look like that was a quick fix, but I kid you not, I spent legitimate hours trying to fix this because the performance was really, really bad, and it did not occur to me that I had accidentally just been creating a mesh hundreds of times every single frame. So yeah, don't forget to move it out of the for loop. It also looks like Unity doesn't like when we create an empty mesh in the global scope, so I'm just going to move that into the start function. Let's try running it and see how it looks. Okay, yeah, it's clearly doing something, but this is not the right thing, so we need to fix that. There are 2 things we need to do. The first is increment vert count, which I forgot to do, so we're just rewriting over the same vertice data. And the second thing is we need to increase accuracy by 1 because the first time we draw a ray, it doesn't make a triangle because there's no last point, and that would leave a gap. So we need to increase accuracy by 1 in order to make a full circle. And we also need to increase our arrays by 3 because we're going to be doing an extra loop. As you can see, our circle is rendering perfectly, so I'm going to multiply the size by radius so we can change the size of our circle. And here's what it looks like with the radius. Now that we've proven our mastery of circles for a second time, we can add some collisions to make it act like real light. We'll make a 2D raycast, which will go in the direction of the point on the circle, and it'll go whatever distance our radius is. I'm going to add a layer mask, which means the rays will only hit objects on whatever layers we set for the layer mask. And we'll check to see if the ray hits. If it does, we'll store the collision point as a vector 2. And then we can just copy all of the code that stores vertex data and replace the point on the circumference of the circle with our new collision point. And if it doesn't collide, we just do the same code we had from before. Jumping back to the Unity editor, I'm going to set the layer mask to be the environment layer, which just means the tiles that the player is able to jump on. And once again, we're doing something, but not the thing I would like to be doing. So it's time for some quick debugging with Mr. 8-Ball. Mr. 8-Ball, why isn't my code working? That is a great point. Isn't debugging always this convenient? So yeah, we need to store 2 different last points depending on if the collision hit or if the collision didn't hit. And just like that, our light effect is working, although it looks real bad because the accuracy is really low, so let's just bump that up a little bit. As far as performance goes, I found 300 rays is about 0.3 milliseconds on my computer, and I ended up turning it up to 500, which was about 0.5 milliseconds. But obviously, depending on your hardware, this could be slightly different. And I thought it looked perfectly fine at 180 to even 60, although the edges get more jittery as you go lower in accuracy. After I finished the effect, I wanted to do a little bit of memory optimization because right now we're creating a bunch of massive arrays and they can be significantly smaller, so I'm just going to go over how I did that. The first thing is we don't have to store the center vertice every single time we cast array, because it'll always be exactly in the center, and that never changes, so we only have to store it once per frame. We also don't have to restore last point because we already stored it in the array, so we can just access the previously stored value instead of storing it multiple times. By doing this, we can bring the array sizes down from accuracy times 3 plus 3 to accuracy plus 2, which is a pretty significant change in size, although realistically won't actually matter, but you know, it's nice to try to optimize things. Now, our light effect at the moment looks like a giant white circle, which, I mean, it looks cool, but I think we can make it more light looking. And so we're going to make a basic shader that just fades the color out as we get farther away from the center. As you know, shaders are terrifying, and everyone is scared of them, including myself. They're absolutely horrifying. However, this one's pretty basic, and it shouldn't be too complicated. I'm gonna go to Create, Shader, and then Unlit Shader, which will just make the most basic shader possible. And the first thing I'm going to do once we're inside the shader is make two variables. One is going to be a color, which will just determine the color of our mesh, and the other is going to be radius, which will just be the size of our circle. Now I'm going to go to render type and change it to transparent, and also set the Q to transparent. This will make sure it renders after all the non-transparent objects, so it can be overlaid on top of them. Then we're going to write blend source alpha 1 minus source alpha. Now, I don't know what this does, although I can guess it has to do with alpha stuff. I don't really know, so I just know it works, and so it works, so we're going to use it. However, what it does is a mystery to me. It's just magic. It's just magic, as shaders mostly are. Now we're going to make our color and radius variables accessible. I don't know why you have to do this. It's actually really annoying, but for some reason you do. You just got to recall them with the same name later. It's kind of annoying, but you got to do it. Now there are essentially two main parts of a shader. You have the vertex shader and the fragment shader. The vertex shader changes the positions of actual vertices on your mesh, so if you wanted to reshape it, you could do that there. We are not going to reshape it because we just spent all that time shaping it, so we're just going to ignore it. On the other hand, the fragment shader is the one that colors your mesh, which is good. That's what we want. So we're going to be working in the fragment shader. The first thing I'm going to do is get rid of Unity's fog thing. I don't know what that does, and I'm not planning on using fog, so I'm just going to get rid of it because it scares me. Then I'm going to define the center of the circle, which, because of how we made our mesh, is just 0, 0. It's really nice, really convenient. From here, we want to get the distance between each point on the circle and the center. From there, we can return a normalized value between radius and 0 based off of our distance using the smooth step function. Now we can just multiply that by our texture color and by our variable color and just return it. Let's make sure to drag it onto our material. And there we go. As you can see, it is completely done and it fades into the edges. We can now change the color and the radius to make it look better. With the light effect now done, I kind of wanted to give a little more impact to the visuals, so I just imported Unity's post-processing effects and added some bloom and a little vignette to sort of give it a better appearance. I also made the light a little warmer so it's a bit more subtle, because I don't really want this effect to stand out too much, even though it's without a question going to be the most computationally expensive thing in my game. So here's a comparison of what we had before to what we have now, so you can see how I've improved the visuals. At least I hope I've improved, although it is a lot better in my opinion. And that's going to be it for today, but before I go, I did want to ask, because my Game Jam game was called Calpurnian Caves, which is a not great reference to gravity as a concept, and I didn't really like the name that much, and I didn't have time to change it. So my question is, do you have any good names for the game? Because I am struggling to think of anything that sounds good. Ideally, it has gravity and cave somewhere in there, but I mean, I'm not too particular if you come up with something really good. And this is me signing off. Mr. 8-Ball, do you think they should like and subscribe on the video?